Hello, this is Brian Kinghorn, and I'm going to tell you about managing trait distributions in MateCell. This is the first of 3 videos. We will go through in this first one the standard control types that we have got for managing trait distributions. In the next video, we will give options to look at entities other than traits, such as age or location, and the possibility to duplicate fields in the main data file so that you can apply more than one control type to any individual trait. And lastly, we'll ask the question, should I manage my traits? And we'll show that you can actually have quite a bit of leeway to change distributions without affecting genetic progress in any great deal. These are trait distributions in a MateCell run, and we have one histogram graph for each of the traits that are involved. If we click on mate selections, we can see the matings that are made for the current solution. And in this column here, we've got the average progeny index. We want to look at not the progeny index, but the individual traits, and we can do that by looking at the file outdata.dll, and this is just to illustrate to you where these distributions come from. So for this first mating in this line here, the average EBV of the parents for birth weight is this figure here, 0.98, and that is a prediction of the genetic merit of the progeny from that mating. When we look across all matings, we use that information to make our trait distribution. We want to be a bit careful though, because these are distributions of predicted genetic merit, which is the average of the parental EBVs, or the genomic EBVs, or if we're looking at indexes, the average of the indexes. They're basically the average of the predicted genetic merit of the parents. So they do not include non-additive genetic effects, and importantly, they do not include environmental deviations. So what you see is only a part of what you will get. In the end, especially for traits of low heritability, you'll have more variation, and you do have limited ability to control the actual results that you will get. But you do have some control, as you will see in this example coming up. The way we manage these traits is to click on a graph. If we click on this histogram here, another window comes up for yearling weight. We can choose any of the different traits, and indeed the markers in the next tab along, marker management, are managed in the same way. And we can jump between traits in that manner, or more simply just by clicking on the trait here as I'm clicking on the main window, the traits change. Then we have the control types, and there are a number of different control types. We'll go through most of those. And there is a checkbox here, invoke. We'll see that later. And there's a weighting for how much emphasis you want to give to the control type. So let's look at increasing the mean for eye muscle area. So if I click on eye muscle area, we want to increase the mean. If I click on invoke, you will see in red down here a little notification that we're aiming to increase the mean. If I click resume, you will see immediately that the mean in eye muscle area is moving upwards. There is another video which helps you to choose the weightings which you use for these things, and a default weighting of 1 has some sizable effect, and it's independent of scale in EBVs and so forth. And that's rather large, so we'll reduce that. It's good to use a sort of logarithmic approach where you would change not by a small amount, but rather a large amount. And the black tick you've got here is the average for all the candidates, sex-weighted average for all the candidates, and the red tick is the mean you've got for the current solution. So you'll see we've pushed the mean up a little bit. If we uninvoke that and resume, then there was a response downwards in eye muscle area, and by putting a small push, it goes upwards. Now, I would take careful note. I would not recommend using this control type to increase the mean. Under much more controlled circumstances, you can achieve what you want with tactical desired gains upwards in this case. So let's click there. And when we do that, we see that we get a gray line, which will turn red if I click invoke. The reason for having this is that if I edit that position of that line, which is now turned red to show that it's invoked. Let's say we want to go up to this point here. If I carefully choose this value here, and we might even manually edit it up to 8, and you see that immediately changed down here up to 8. Then if I put a weighting of 1 and invoke, let's resume. And we'll see that that's a desired gain. And the control we've got is we're going up by exactly the amount we want. It is at quite some compromise in our genetic gain and co-ancestry here. And there are 2 ways that you can control that. One would be to reduce the weighting on achieving that outcome. Let's go down to 0.1 and resume. The thing is, you don't have much control over what happens here. In fact, there's very little control over that. It's much better to leave that weighting at 1, and for control types like this, achieve the compromise by reducing your ambitions. So let's make this now 7.6. You'll see this red line has moved, and if I resume, at a smaller compromise, we've found we've made the achievement exactly as we've aimed. In fact, we might not be happy with this compromise, and therefore let's go back to, let's say, 7.4. We get that 7.4, and we have made a smaller compromise. If you find it difficult to read this on the small graph, then there's a little tip here. If I click on the graph by holding down the Shift key first, then it will occupy the whole area. And then if I hit the Control key, I can get back down. Okay, it may well be that what you want to do for eye muscle area is not so much have an average above a certain value, but have it cut off. So let's go to set minimum value at boundary, and I'll move that boundary down to, shall we say here, it's now sitting at 6.7 or so, and I resume. We're beginning to achieve that. MateCell's not interested in the values above the boundary, it's aiming to get most matings or all matings above it, and this has happened at quite a small compromise perhaps, so we might achieve that with greater confidence if we just whack that up to a weighting of 10. We get it immediately at a small compromise. So again, we're looking at predicted genetic merit, but you see we can get what we want to achieve. I'll bring that down and put it in context with the others. Okay, now we will look at a different trait. I'll uninvoke that, and you now see the value of the invoke button. We have worked to achieve perhaps this minimum value. I don't want to edit that by removing it. I just simply take the invoke off. Let's say back fat, we want to reduce variation. So if we decrease variation in back fat, leave the standard weighting at 1 to see what happens, invoke it, resume, and we can see the variation in back fat is coming down. And at some compromise, there's quite a considerable effect here. There are two things I want to show you here. One is that if we put a very small weighting on back fat, let's make it 0.01. Now that initially you would think would have very little effect, and at this stage it has little effect, but near the end here you start to see some reduction in variation being quite successful. The reason for that is that the reduction in variation is being achieved largely by mate allocations. It's not changing the animals that are mating and the number of matings allocated to them. And because there are no other effects in the analysis, including progeny inbreeding here, that are impacted on by mate allocations, that small weighting has some impact. Well, let's look at another one. We may not be happy that that variation is small about this particular point. We may want to have a little bit more back fat, but less variation. So we can decrease variation about an optimum and therefore take it up. Let's leave that where it is, which is just above the population mean. I'll put the weighting back to something meaningful and resume. And so we're not going to necessarily get a result which is right on that mean. Let's have a look at it more closely. It's looking for variation about that point and is doing that reasonably successfully, so it has reduced the variation and increased the mean to a certain point simultaneously. We might not be happy with the compromise, so we might reduce that weighting, and this is where judgment comes in and a bit of play. And by reducing that weighting, you'll notice that the solution improves. It was down here, it's now looking for something more up here, and the result is still quite reasonable. And just to see how much change we've made, let me uninvoke that, and if you keep your eye on the graph when I press resume, you'll see that's the impact we've had if we go back to essentially random mating. Let's lastly look at intramuscular fat, and we'll go for target bimodality, invoke that, and I achieve the bimodality by left-clicking for the left mode and right-clicking for the right mode. And I'll say that I want to have the target percent in the upper group. Shall we make that 30% and resume? The analysis looks for a solution, and you'll see that we're getting about 30% in that upper mode. And this might be that you want to produce 30% of your bulls for a high intramuscular fat market for export, perhaps. The rest are going to customers who are buying bulls for domestic market. That's quite a strong result with quite a big compromise. So we might decrease the weighting in that. You would find that we still get quite a reasonable response. And the compromise is still a bit smaller. And to finish now, what if you go through quite a bit of operations to find these different values and weightings, and you want to be able to save them so that you don't have to go through that again? Well, if we look at the mate cell INI file, at the bottom of it, there are all these factors which relate to what we've been doing for traits and also for markers, which we control in the same way. If I go back to the run and click the save button and come back to mate cell ini and reload it and see the weighting factors that we've used, the control types, and the target values, which are only filled for what is required for the particular control type. So there's that bimodality for the fifth trait, 30% in the top distribution, and these are the targets for the distributions, and the weighting is used. And control type 9 is bimodality. Okay, we've looked at standard operations. We're now going to look in the next video at advanced operations, and then some discussion in the third video about the value of managing your traits and the circumstances under which it's a good thing to do. Thank you for listening.